All right. Mr. Konarska, in all the years that you were in automation and robots and whatever, what was your most challenging design or system that you put in? What was it? Was it concerning welding, cutting, pick and place? What was the hardest thing you had to do?
Yeah, so I think it was probably a system where it combined just about everything that you just said right there. So it had cutting, it had material handling, it had laser welding, it had marking, conveyance. And so basically it was integrating a lot of different processes. So it was on the far end of the spectrum from a factory automation standpoint, where you're essentially integrating many, many different processes. And then obviously the takt time of the entire system is only as fast as the slowest of those processes. So in that particular situation, there was some processes had 2, 3, or 4 stations, while others may only have 1 or 2, depending on what takt time per station. So extremely complex system.
Okay. Mr. Scott, when you're formulating these wires and powders for spray, what is the determining factor of, or what do you rely on as far as picking the alloys that you do use, whether you use chrome, boron, whatever? What is the determining factor usually?
Yeah, that's really simple, John. Good question. Periodic table and a dart.
Do your customers normally come, or do the customers normally come knowing what they want, or do they rely on you to develop a product for them?
Well, customers just want a solution. They don't really care how you get there. So it's mostly experience, lots and lots of trial and error. To do one alloy system might be 100 to 200 different iterations, each of which is tested. And you keep going until you find one that works.
Okay. Is this a quick thing, or can it last several weeks or months sometimes?
Could last a couple of years.
Holy cow.
Well, my mom was Irish. We don't give up easy.
I've got a follow-on to that.
Okay, go ahead.
You've got 2 different types of customers. You got some customers that know everything, and then you got other customers that don't. Which are the easier, how do you deal with those 2 different ends of the spectrum?
If the customer that knows everything brings a checkbook, we can talk. If they, it's better to deal with somebody that looks at the problem and a solution, and you work together to try to figure it out.
Yeah.
And that's a lot of fun.
Okay. Mr. Holdren.
Yes, sir.
H2S. Are there many requirements, or are there calls now for doing the standard strain tests with H2S environment? Do you have a lot of calls for that, or are there many procedures requiring that to qualify?
I've never been posed with that question. You know, I mean, I've never had to qualify a procedure with those additional constraints. You know, the only constraint that I've worked to is just the MRO 175 hardness limits.
Okay. All right. How many labs, do you know offhand, how many labs in the U.S. have the capability to do those types of stress and strain H2S environments?
There's only one here in town. Is Exova the only one that? I think they're the only ones here in town, and it's probably, you're talking one hand in the country.
Do that?
No.
Okay. Mr. Perdermo.
Yes, sir.
You know, I watched with great interest this morning your presentation on the projects and the different phases of completion, and when the welding engineer comes in and more or less, wait, let's put it another way. When they have to bring the welding engineer in for consideration, do you find that most projects adhere to these established guidelines, or is the welding engineer sometimes brought in as an afterthought?
So for those who have the resources always brought in to weigh in, sometimes what happens is they have someone that weighs in as a welding engineer who doesn't have the background to be one. So I guess with that, I'm trying to say that the input is always welcomed, but it doesn't necessarily come from the right person.
Do you, as a follow-up, do you find that there's a lot of resistance to the corporate welding engineer of the user by the fabricators, or is that sometimes just?
No, normally well, I would say that I guess it depends. I guess as it was just mentioned that if you bring someone that thinks that knows the answer, is welcome most of the time to help find the solution. I think that sometimes the problem is that you may have people that think they know the answer, but it's not really the answer, and they push themselves hard to make things happen their way without listening to the expertise of others. So
Yeah.
normally when I deal with fabricators, I always listen attentively what they have to say, because obviously they're the ones that fabricate and do things frequently, and there's always opportunities to learn from anybody.
Okay. This is back to Nathan. I have some older WPSs, and they don't have all the documents that you talked about this morning. Can I still send it to the customer for review? And I'll add on to this. Is a WPS a WPS, or can it be amended once the end user customer signs off on it?
If the WPS is amended after the end user or customer signs off on it, then it goes through the whole review process again, unless the end user has some type of statement of conformance. For example, there may be a customer that says any revision of this WPS is valid so long as any essential and supplementary essential variables are not changed. I've seen that happen in the past, but more often than not, if the WPS is revised and used in production, that gets resubmitted to the customer, ideally before the work starts. And if you have a welding procedure package that doesn't have all the documents I listed, it's not the end of the world. Many of those documents are actually required to write the whole package, so that's on, you're going to have it. But if it's an old package where you really can't find any of or some portion of that documentation, it's okay to provide it to the customer and let them know, hey, I'm missing this document, or if they don't require it, okay, then you don't have to include it. But at a bare minimum, you'll have to give them what code requires for that prospective work, and what I've shared is usually far beyond that.
Okay. Bill?
Yes, sir.
Why is the petrochemical industry affected more by brand or trade name specific requirements than other industries?
Because many of the API recommended practices or documents make that a requirement. And in years ago, the multinational companies did that to try to get some consistency in their various projects around the world. Makes a lot of sense. However, now that you have everyone gobbled up in merger mania, I just had it 2 weeks ago. The company decided, oh, well, we're just going to change the name of this. I said, well, if you do that, you're going to block out some of your very good customers. And they said, we don't care. I said, well, excuse me. And they said, no, it's so much a small part of our effort. We don't care. Well, if you're the guy with the utility or the refinery, you care big time. So this indeed is an issue. And petrochem seems to be more dependent upon this, because many of the alloys they use don't have an AWS classification or an international classification. They're specials. They're what AWS determines or calls commercially insignificant, because a ton might be used for the entire world in a year. Well, it's hard to make money if all you're going to sell is a ton. So many of the companies have decided not to be involved. And this creates some interesting challenges. There have been some specialty outfits in the past that, okay, it cost a lot of money, but they would keep it on the shelf. even in small quantities. It was like a Rolls Royce. People don't care what a Rolls Royce costs. If they want one, they buy one. Well, these companies have been slowly but surely gobbled up by, I'll call them the big box companies, big box stores. And they look at number of turns per year and, oh, we can't have that on the shelf. And they said they'd rather sell $3 a pound stuff than $60 a pound stuff. Well, if it costs $60 a pound and you need it, you don't care because you may only need a tube or a carton. But nevertheless, you need it. So this is becoming, even weekly, a bigger problem in the industry. And I had one person contact me, say he heard my talk today, and he goes, we can get you down that 500 to 1,000 pound range. I said, okay, I'm interested. Because you can't go to the big box stores anymore for that.
Hey, Bill, just to kind of follow up on that, is there just too much of a mismatch between the base materials being designed and the welding consumable manufacturers that they're basically making materials that can't be welded? If there's only a ton a year of filler metal required, is there an alternative from the actual base material?
Gary, in some cases, the answer to that is probably yes. But in many of the industries, they're creatures of habit. Hey, this has worked for 50 years. We're going to keep doing it. And they're reluctant to change. Now, there are some applications where, for example, the high carbon stainlesses, the HK40s and HB50s, MBs, and things like that, yeah, they're pretty special. But they're in very special service, like, reformer tubes, that sort of thing. And there's not a real impetus to go to something else because what they've got works. And to do a redesign, and quite frankly, we are losing that ability anymore, it seems. I mean, a lot of that was handed down from one generation to another. Well, that's not happening now. So some of it is created, but there's still a lot that it's, okay, this is still the best alloy for the service. And there are restrictions too. For example, there are environments where you don't dare use nickel-based alloys. For real high temperature stuff, sure, you can go that route. However, if you've got a sulfide environment, you don't dare do that. Jorge can tell you some horror stories I know from his past where people have used high nickel materials and it just disappears or fails catastrophically. So there are some legitimate reasons of why we need to maintain these alloys.
Well, Bill, also, as I recall, some of the alloys need to be super clean for the furnace when they're made, and only right after they've re-bricked the furnace can they take and make the alloys pure enough. And since they're not rutted as many heats, and there's not as many orders, that time to schedule it has drug out longer and longer and longer. Is this not true of some alloys?
It is absolutely true. Typically, well, let's say a re-brick on a furnace in the past, we've tried to get in line in the next melt, the first melt after the re-brick or the second melt after the re-brick for some of the real high-end chrome mollies. And in a 200-ton melt, you can get some really clean stuff. Well, we're not getting 200-ton melts anymore. We're lucky to get a 40-ton or a 20-ton. Well, and of course, as that goes down, the price goes up. But on many of these alloys, the price, it is what it is, and people will pay it. But there is a function of, economy and scale, and we're just not seeing that anymore because people aren't going for the big melts. I can go to somebody, for example, like Timken, a superb melter, 200-ton minimums across the board. Well, one of the things I don't need 200 tons is 10 times my lifetime. Well, even on a good day. So you don't go to Timken. A fine outfit, but not anymore. I mean, you just can't afford to buy something and just let it sit on the shelf that long.
Well, also, is there not a shortage of green rod where the melters have taken and made up product and drawn it out to green rod state, and they're just not having that inventory anymore? Is that correct?
Yes, and a lot of that happens to do where they were used to do 200-ton melts. Now they're down to 40 and or even 20-ton, or maybe 4-ton in some cases. So there just isn't as much inventory because they're saying, well, we don't move as much, so we're not going to have it sitting here. The hot rolled rod is not, or the ingots are not the expensive part. It's the processing is the expensive part.
I think Mr. Holdren has a follow-up here.
Bill, are there any opportunities for replacing some of these products with a composite product?
The answer to that is yes. And we are dabbling and have been for several years trying to use metal core products where somebody was using bare wire, going with metal core products. The challenge there is the metal core products, or even the flux core product, the oxide levels are significantly higher.
Yeah.
We don't get the same actual in-service properties or creep ductility in many cases. So there some alloys, yeah, you can get away with that. Others you cannot.
Okay. Joe,
Sir.
in your many years in the business, have you ever seen the end user / utilities do business the way they're doing now? And I mean by that, skeletonize their weld engineering group, putting off ordering until the last minute and so forth.
Yeah, it's worse now. The just-in-time philosophy, rather than planning out a project, and if you plan it out, you're going to save money in the long run. But not the wasted time and the scrambling at the last minute. But everything's cost-driven these days, and especially in the oil patch and where I'm active these days in the drilling production of oil and gas wells. Everything's been cost engineered right down to the ground.
Right.
And you've got to prove value. They will not speculate.
Mr. Holdren, what can a company budget as far as time and monies to do a 4130 weld test complete with CTODs, step cooling, and whatever else is required? How long would something like that take start to finish, and what would the approximate dollar amount be for that testing?
I don't have any personal experience with the CTODs, but with just standard API and NACE and ASME requirements, you're looking at least a 3-week turnaround, and
That's if the plates are already welded? Or
no,
pipe
that's
to weld and all?
weld and test and report, and cost anywhere from 12 to 15,000
Okay.
for that. Now, I don't know. I mean, Nathan's had some experience with CTODs, so you could probably
Jump in, brother.
Sure. So CTODs are usually referencing a spec like API 1104, and at that point, any filler metals that you plan to use in production are usually going to be heat specific, which means you get to re-qualify every heat, at least for some portion of the testing, if not all of it. In my historical experience, we just did all of the testing of every new heat. And at that point, a single PQR can run you 45 grand in welding and lab costs, and that's ignoring the base metal. So if you're having to test a new heat or an extra postal heat treat, that's another 45 grand, and that's another 45 grand again. Like, this can cost snowball very quickly into something that no one actually budgeted for, and
How many weeks?
that can push out to 12 to 24 weeks. The longest qualification I've actually done, I brought up in the presentation, took over a year, but for usually a CTOD style qualification with a high strength alloy like that, you're probably pushing around 12 to 24 weeks.
I remember Peter Kenny giving a presentation, I believe at one of your seminars, where there were only 6 welds that had to be made on this project, and they spent 10 times as much money qualifying the procedure as what it cost to do the production welding.
Yeah.
To build on your point, that is actually what happened with the qualification I had. We ended up welding 3 or 4 weld test coupons for 1 production weld, just to get all the extra properties the customer wanted.
Welcome to nuclear, guys.
What's that?
I said, welcome to nuclear.
Well, let's talk about that for a minute. You know, from what Christy said a while ago, and Buzz and everything, and now people freezing their butts off 3 weeks ago. Do you think there might be a reestablishment of some nuclear on the horizon here, or are there too many libs?
I guess, you know, big part of my career was building nukes and then figuring out how to fix them. I'd like to see that come back, but what's so frustrating is we had the technology in the late 40s. We were building packaged nuclear plants that would fit in a 40-foot container. We were shipping them around the world to outposts, Army outposts in Alaska, Antarctica, godforsaken places. And these were modest-sized plants, packaged plants. We have countless package plants, if you will, as a propulsion system for our nuclear submarines. We know how to do this. It's not a big secret. We've got a lot of package plants there. Our last effort to make package or cookie cutter plants was called SNUPs. I forget what that actually meant, but everything was supposed to be the same. The problem is that everybody had to tweak it a little bit, each utility, and then the NRC and each division had to tweak it a little bit, and they blamed it on different seismic conditions in different parts of the country. Well, even as a young engineer back then, I couldn't understand. Well, hell, just do it worst case. Make them all the same. Pour the foundations, modify the foundation, and bolt it to it and let it rip. But we don't seem to have the wherewithal to do that. There's some great designs on the drawing boards and in the testing, and to get their designs approved. But I'm not sure that we have the wherewithal or the intestinal fortitude to proceed. Can we do it? Sure. Should we do it? Sure. Everybody, they complain about the waste. If you look at the amount of nuclear waste that's been created since the beginning of the Manhattan Project, I think I saw a thing where it's the size of a football field, 6 feet deep. And that includes, and only commercial 6 inches of that, and the rest of it's the military. So, I mean, you know, okay, hazardous waste is an issue. It probably wouldn't be an issue if we decide to make it a priority. I mean, we're real good at addressing problems when we have to, but we're not so good if it's a kind of oh, well, that's the other guy's problem. Let him worry about it. I would like to see that because it's clean, it's reliable. I'm actually surprised what happened in Texas with the service water freezing up. I mean, as anal as we are on the redundancy on nuke plants, it would be interesting to see the root cause of that, because I just find it amazing that somebody missed that. Because these guys are really, really good on the dual and triple redundancies on plants and all these what-if conditions happening simultaneously. So it'll be a learning experience on that. But yes, John, I would like to see it come. I know we know how to do it, and would be very creative on this, but I'm not sure we have the political or the public wherewithal to do so.
Well, wasn't there also the whip site or whatever that it was called in southern New Mexico, out in the abandoned potash mines, where there's no groundwater anywhere within 80 miles of it? Wasn't that site developed to bury the nuclear waste, and then they ran into problems with transportation?
Well, you mean Yucca Mountain, and that was in Nevada.
Oh, okay.
And in fact, when I was building the Perry plant up on Lake Erie, the Morton salt mines were in Fairport Harbor, about halfway between Perry and Cleveland, Ohio. They're just east of Cleveland. And there was a proposal to use the salt mines to bury nuclear waste. And people were just up in arms. Oh, you can't do that. What if it leaks? I say, well, wait a minute. If there was any water leakage, there wouldn't be any salt. I mean, these things are miles deep and miles out under Lake Erie in that particular case. Now, there's all kinds of places that would probably be ideal candidates to house nuclear waste. But no, instead, we're housing it at each plant. That sounds real safe if you look at it from 30,000 feet. And some of it just doesn't make sense. It knee-jerk reactions rather than thought out.
Yeah, and then one final nuclear thing. Weren't the early aircraft carriers outfitted to where they could back up into a harbor and hook onto the grid?
Yes, in World War II, not the carriers, but battleships, the electrical generation capacity of a battleship was such that they could pull up to the piers in the Hudson River and backfeed what was the grid then and run New York City off of one battleship. Now, our carriers today have significantly more power available at their disposal. And you're trying to steal a chapter out of my novel that I probably will never write. But
Well, look here, you can will that novel to me and I'll publish it, okay?
but no, but there's lots of things we could do.
Yeah.
Lots of things, but we just, for some reason, choose not to.
Yeah.
I'll be
Jorge, back
Yes,
to you,
sir.
brother.
Yes.
Way back in your early days, you worked for a company that had an approved vendors list. Can you explain a little bit more about approved vendors list actually is, and what all is involved in getting on an approved vendors list, please?
Yeah, so there's a wide range of ways to go about that. On the upper end would be to actually do audits on suppliers where the I guess the user with the internal resources that they may have in their corporate engineering office can actually go and look at their quality system, look at the products they make, and then among a group of people decide whether that supplier can be included into the approved vendor list. That's expensive and difficult to maintain. And then on the opposite end to that, you'll find people that hear that some competitor is buying from A, B, C, or D supplier, and then they add them to their approved vendor list with no regard for understanding if they provide a quality product or not. But even in those cases where there is a qualification system in place and procedure, you will find cases where somebody added a vendor to a list, and their products may be questionable, and they are on the list, right? So anyway, so it's an expensive proposition, difficult. The idea is well intended, but it costs money to maintain. And I guess based on the what you see now with the current market conditions, there isn't really a lot of money put into going qualifying new suppliers from some of those big companies, which results in other problems because you may be leaving outside your list good suppliers that are trying to get on the pre-approved list so they can sell to you a good quality product. So again, it's very difficult. So again, when I participated in some of those, it was always fun to go and do the audits and talk to the suppliers and all that, and actually get workout plans to improve with some of the issues that had been identified. And in some instances, you'll find, especially in the emerging markets, suppliers that shouldn't be on a list, but the procurement organizations looking for saving money, they push to get those people on those lists. Again, it's a very complex mechanism, I guess, because on one hand, if you're buying quality, you pay more for that. If you're not buying quality and you're buying from the emerging markets, you're sacrificing quality for money, and then you may not get what you need, right? So somebody has to do the math and figure out what works.
Okay. Now, I'm just the messenger on this. Mr. Holdren, does a CWI have the qualifications to amend the WPS?
There may be some out there that do, but it's not because of that credential.
Who has the right to amend the WPS?
Anybody that can run a PQR and prove that it meets the requirements.
Okay.
But they can't pencil whip it. I mean, You know, they have to have lab results to show that if there's a change. That's what the code's there for, to say, okay, you've tested it, and based on these tests, this is your operating range.
Great. All right. Well, I think we've extinguished enough brain power here this afternoon. I want to thank all of you for tuning in and listening. I want to thank you for watching during the day. And remember, there were codes on all of the presentations. If you want PDH credit hours, you need to have all of those codes, and you need to submit them to Johnny. On the site, there's a place to send them all in, correct? And if you handwrite stuff and we can't read it, too bad, all right? Because I've already played that game a number of times. So type it in, all right, or get your wife to type it in for you. But we appreciate you coming. The next one will be in September. We'll get you more information. Hopefully we'll have it live here at ARC, and we can put about 60 or 80. If you like one another and you put your mask on, we can probably get more in here. But I really miss having everybody in here and having the back and forth during the presentations. And I think that's part of what we do, is to see one another and talk to one another. And like Nathan said, when he ran into problems, he went out and asked people, and that's in the industry. We are the welding industry, and we are the ones that'll solve problems. So with that being said, I appreciate your time, and we look forward to seeing you in September. Take care, stay healthy, and hang in there, hang loose, brother. Aloha.
Thank you. Bye-bye.
Bye-bye.
Thank you,
John.
gentlemen.
See ya.
See you guys.